We're going to move into our second type of inferential statistics. Our first one, as we did already, was the confidence interval, and our second type is hypothesis testing. So before we tried to capture what we thought the truth was, this time we collect some sample information and try to disprove what we think was the truth, if that makes any sense. Let's go slowly through this and see what you think. So when we set up a hypothesis test, we have to state our hypotheses, and we'll do that with parameters. Parameters are mu and pi. Those are the two that we will use. First is our null hypothesis, as you see here, and we denote that as H with a little subscript 0. That's a null hypothesis, HO, H subscript 0. And that is what is assumed, what is commonly known, like 50% of all people on the earth are females, or the average person sleeps 7 hours a night. And then we take samples, and from that we will try to disprove it. Either we think it's greater, or we think it's less, or we think it's just not that, right? We think it's different. So it's either greater, or it's going to be less, or it's different, okay? So I wrote some examples of how we'd like to write. I've got 4 of these right here. Different ways to write null and alternate hypotheses. So null is our original claim, the alternate hypothesis, which is H subscript 1, that is our competing claim based on our sample. So here we go. So I have a null hypothesis. I do a null hypothesis colon, then I have mu equals 7. So the population mean equals 7. So my sample information was something smaller than 7. So my alternate hypothesis, that's H subscript 1, I put mu is less than 7. So that's how I'm going to write my hypotheses for that situation. For my next one, I have the null hypothesis, colon, oops, I wrote something wrong here. Let's take that off. I have mu equals 300, and then I have, we think that it's different. So we didn't say it's less or it's greater, we're just going to say it's different. So I put a not equal sign for the alternate. Mu is not equal to 300. Let's look over at this one. Now we're going to move into the world of pi, right? So, you know, we measure things in the world in either means or percentages. Baseball is a great thing for that because your batting average is actually a percentage, and average number of games played or average number of innings played would be a mean. So here we have a null hypothesis where pi is equal to 0.5. And then we have the alternate one, which means I must have had a sample that's less than that because that pi is less than 0.5. And then my last one, I have another one for pi, and I don't have any graders in here. I can't believe I didn't do that. So the alternate, the null hypothesis is pi equals 0.99, and then I have the alternate pi is not equal to 0.99. Let's mix it up. I'm going to make this one greater than, just so we have one of each. So my 3 types of alternates would be less than, greater than, or not equal. Those are the 3 types of alternate hypotheses that we can have. Either less than, it's greater than, or it's not equal to. All right, so the alternate hypothesis is the type of test that we have. What do we mean by that? Okay, well, here let's take the first one that we had. I'm going to rewrite it over here. We have the null hypothesis mu equals 7. That's the population mean equals 7. But my competing claim, my alternate, is that mu is less than 7. So less means left side, right? My values that are less than are on the left side. So my normal distribution that we're going to use for this problem is going to be based on the left side. And we'll talk about what that means in a second. All right? So then if I had a greater than symbol for my alternate, I would have it based on the right side. And then if I had a not equals, I have it on both sides. So let's see. Less than is a left-tailed test. Greater than is a right-tailed test. And not equals is a two-tailed test. So we have those 3 types. All right, so what makes us think that the original claim, the null hypothesis, is not true? How far away does our sample have to be? So at the beginning, we will have a decision to make. Usually our book gives us this. They'll say, hey, make it 1% or 5%. So we have this thing called alpha, and alpha is called the level of significance, and it's the size of the rejection area. So we go to the very left or very right, depending on where we are, and it's usually 1% or 5%. So if I have my alpha here, this is a left-tailed test. So on the very left-hand side, we're going to say alpha is 5%. So the very left 5% is my rejection region. So if I have my sample, that's less than 7, and it ends up right there, it didn't make it to the rejection region. So I'm going to say, I'm not going to reject the null hypothesis. Okay? We're going to say it's okay. We're not going to reject it. But if I end up on this side with my sample, we're going to say it's far enough away that the the null hypothesis is no longer true. So if my sample ends up in the rejection region, we're going to say the null hypothesis is no longer true. So we can do it for the left side, we can do it for the right side, or we can have a split tail. And we'll try one of each with our examples. We're going to do it for mu. We're not going to do them for pi in this class, so just for mu. We're going to learn it with 1 sample and 2 samples for mu. All right, so our next video, we will talk about the different tailed tests.